All right, it looks like the arrival has stabilized. So why don't we get started? So welcome. This is a webinar for the Masters in Data Science that's about to start at Lehigh University. So we're glad to have you here. We look forward to answering your questions, and I want to point out that you can post your questions on the chat at any time. Maybe someone will answer you directly, or we'll make sure we catch your questions at the end. We will leave time at the end to answer questions as well. But I have some slides to go over that describe the program and talk a little bit about Lehigh, and hopefully we'll maybe answer some of the questions in advance. So let's get started. So first of all, again, welcome. My name is Brian Davison. I'm a professor in computer science and engineering. I'm one of the 3 collaborators that have put together this program, and the other 2 are also here, and I want to let them introduce themselves too. So Daniel, you want to go next?
Sure. Welcome, everybody. Yeah, my name is Daniel Robinson. I'm an associate professor in the Industrial and Systems Engineering department. And I work in continuous optimization for my research area, and very excited about this program. So thanks for coming tonight.
Hey, I'm Parv Venkita Subramaniam. I'm an associate professor in the Electrical and Computer Engineering department. Yeah, thank you all for being here. I work in signal processing, information theory, information sciences, more recently in data science and machine learning as well. So it's nice to have you all here, and hope you have a good time.
Thank you both. Now, I should say that this is a new program, but we have been educating our students in data science and the technologies and techniques and methodologies that go into data science for a long time. And so I just wanted to highlight that for the moment, just to say our students then end up going to places that value that education. Now, many of the students that we've graduated have been from our PhD program, but that of course is an option for you after the master's too. But also some of these are from master students that we've had as well. But lots and lots of companies, these happen to be mostly the bigger companies, sort of obvious ones that would use data science, machine learning kinds of efforts in their businesses. But all the big companies, and certainly the major companies even around the world. I also want to thank 2 people that are on the call as well. We've got 2 students, well, 1 former student and 1 current student, and I want to ask them to introduce themselves too. So Nick, why don't you go first?
Sure. Good evening, everyone, and welcome. My name is Nick LaRosa. I'm a recent graduate from the Electrical Engineering MS program with a research focus in a data science related area. Yeah, glad to see all of you here. Thank you all for coming.
And Ishan?
Hello, everybody. My name is Ishan Adigarla. I joined Lehigh for my master's in computer science 2018 and graduated in 2020. And recently I decided to continue with my PhD in computer science. I also mostly work in computer vision, deep learning, and data science, and happy to be here and answer questions later.
Thank you. So we asked Nick and Ishan if they would join us tonight, mostly so that you could ask questions of actual students and not just the faculty who can pretend to know what students are thinking or feeling. So hopefully they'll give you a more unique, a more authentic answer than we might be able to. But please feel free to ask them questions as well as any of us. All right, so you're here for data science, and hopefully you have a little bit of a sense of what data science is. And certainly it includes all the things that you see here, everything from information and data gathering to visualization to analysis to building structures and extracting useful valuable knowledge. Yes, some programming too. Lots of things go into data science. quite a broad topic, really. But maybe first we'll start with a related topic, which is big data, which is relevant to data science. It's part of what makes data science so popular and so interesting and so valuable. But maybe we'll define the big data first. So what is big data? Well, a simple definition would be it's data that is large enough that you can't really process it easily on a single machine. And so big data problems typically require clusters of machines or some kind of specialized computation to be able to reasonably calculate or extract some useful information from that data. So if you've got a terabyte hard drive or 2 terabyte hard drive on your laptop right now, yeah, that fits on your laptop, but it might not be, the laptop might be too slow for you to get anything out of it quickly. You may need to wait, days or weeks, depending on what kind of analysis you're doing. But where does that data come from? And so in this diagram, I give you a little bit of a hint of where it might be coming from. And just the online presence that the world provides, over 5 billion people, most of them are accessing the internet in some fashion via a mobile device. But they generate a lot of data, and you might recognize a bunch of activities or applications on this diagram that maybe you used in the last week. And that they reflect what's happening so often over the day. And so in 1 minute of a day, you'll see that Google is conducting almost 6 million searches, and that Venmo, people are sending money in Venmo over $300,000, and Slack is sending almost 150,000 messages, and so on. Facebook, YouTube, Netflix, they're all contributing to the data that's being created primarily as a result of people's activity online. And so the data that's being consumed by people was astronomical, 79 zettabytes. And no, we're not going to try and define that tonight, but it's a big number, and it's only growing larger and larger every year. But it's not just data that's online. It's data that's being collected all over the place. Everything from security cameras to energy production and extraction and delivery. It's medical data. It's telecommunications data. It can be sensors in a manufacturing facility. It can be the tweets that people share online and communicate with online. All of those things are data, I mean, sort of in a basic sense, but they're also data that can be used to extract useful information. And that's the purpose of data science, is to be able to extract useful, valuable information that can expand our knowledge, help us to know about trends or patterns that we might not have known about before, or to be able to provide services that are valuable. Maybe it's detecting something in a security camera, or making a prediction about something happening after sensing the vibrations in your car, or in some industrial process that maybe something isn't quite right, and so that there should be some kind of preventive maintenance going on. But that data, whatever the source, can go into an analytics pipeline of some sort, get the patterns of interest out, do some analytics, maybe visualize it, communicate it, and then act on it if it's valuable information. So that's one example of a typical pipeline for data science, and helps illustrate some of the other sources of data. Some of you might be here because of the hype around the data scientist job title, that these are in fact quite valuable jobs. They tend to rank very highly in career satisfaction. They tend to rank highly in compensation. They almost always require graduate degrees. And so that's one of the purposes for our new new program that we're going to talk about. And yes, you see that some of these articles are older. I happen to like them because the 2012 one was one of the first one. That's the middle one from Harvard Business Review. It's one of the first ones to recognize and sort of popularize the term data scientist. And it happened to be co-written by someone who would eventually become the first data scientist of the United States of America. He actually was appointed the data scientist in I think 2015 or 2016. But it's been a hot job, and one of the hottest, and sometimes the hottest, for a number of years running. And so here you see the Glassdoor ranked at #1 in 2016. Well, it did again in 2017 and in 2018. And in more recent years, it's sometimes been a #1 and sometimes been #2 or maybe #3, but it hasn't left the high visibility. All right, so that's a quick reminder about why you're here and where is Lehigh. So Lehigh is in Pennsylvania in the United States. We're in the Northeast, and we're in particular close to the eastern edge of Pennsylvania. We're in Bethlehem, Pennsylvania, in the Lehigh Valley. Lehigh has a quite large campus, some 1,600 acres, 3 campuses that are on both sides and on top of a small mountain called South Mountain. It continues to rank highly in general in many different kinds of rankings of universities. We're a medium-sized school. We've got about 5,000 undergrads, and that's maybe up to 5,200 undergrads, I think, these days, and about 2,000 graduate students. We're organized in 5 colleges: arts and science, business, education, engineering, and health. Health is brand new, only 3 years old. We're still growing, and that's one of the places we're growing quite a bit. The data science program is in the engineering college, the P.C. Rawson College of Engineering and Applied Science. It is not the largest undergraduate program, but we have the largest graduate programs. We've got over 150 full-time faculty members, 8 departments, multiple buildings across 2 campuses. And so we really do support or provide the educational programs for over half of the PhD students on our campus, and similarly support see that productivity in terms of papers published and research funding and so on. And about 1/3 of our engineering faculty have won awards, in particular one called the NSF Career Award, which is for young faculty who show exceptional promise and provides them with some long-term funding. This happens to be a picture of where the engineering college is headquartered. This is Packard Lab on the main campus. Now, onto the program itself. Our master's program requires 30 credits. And for us, that means 10 courses of 3 credits each. I already mentioned that we're organized under the College of Engineering. And I should point out that means it's not under a department. And that's important because we are an interdisciplinary program. You can see that we've got 3, the 3 organizers, the 3 founders are from different departments and different programs. And so this program itself, this new program, is under the college as well for that reason. And so it's interdisciplinary, both because of who is setting it up, but also because of the content. It turns out data science is really an interdisciplinary science. So if you think about it, maybe you've seen diagrams of Venn diagrams and such before. Typically, you might see that there's a computational component to data science. There is a mathematics or statistics component to data science. And then there's knowledge about some domain, some problem area, some business area, wherever you're going to apply the data science. You end up needing at least those areas of expertise to do well. And so most of the courses in this program are taught by faculty from these departments, but we also have electives that come from departments across the university. The program itself is oriented towards students with a certain level of math and computing backgrounds, and I'll talk about that in a moment. The shorthand way of saying it is that we're oriented a bit towards STEM students. So if you have an undergraduate science or engineering, typically you'll have the background that is needed for the program. But it doesn't expect that you've had any data science background. And so the master's program covers all the fundamental concepts, all the topics that belong in a data science program. The program can be completed in 1 year. We've designed it explicitly so that you could start it and finish it in a little bit under a year. But it can be longer. That's up to you as to how quickly you want to go through the requirements. It is available both to in-person and to online students. And so you can even mix and match. Some courses you might take online if you're here. The students can also be full-time or part-time. We've ensured that you can finish in 1 year, but we certainly don't require it. And we can imagine students taking a year and a half, or if they're doing it part-time, that would be over multiple years. Okay, so what do you need to be admitted to the program? Well, we do need a bachelor's degree, and we're by default asking for a bachelor's degree with a GPA that's equivalent to a 3.0 out of a 4.0 GPA. We expect that you'll have 2 semesters of calculus. We expect that you'll have had a course in probability or statistics, a course in linear algebra or linear methods, and some kind of introductory programming experience. We are waiving the requirement for a GRE scores for this year. We might bring that back in some future year. For those who are not native English speakers, there is also some language proficiency requirements, and so I've highlighted the core of the scores that you need to have in each of the 2 major tests that you can take for that purpose. But it is waived if you just finished a degree in the US or in many English-speaking, English-centric countries. But if there is, on all these requirements, so I list them as requirements, but perhaps there are extenuating circumstances, and we're willing to listen and consider that as well. All right. So the program itself, we're doing rolling admissions, which means you can apply now, you can apply next month, you can apply even up to June 21st. But we'd really prefer that you not wait until that date to apply. We'd rather be able to decide and welcome you into the program and get you started with your planning before that, because the first day of classes is early in July 5th. And then the first day of the fall term is near the end of August, and the spring term near the end of January. And then if you're on a 1-year schedule, the less than 1 year schedule, you'll be able to graduate on May 21st. And so if you're doing this in 1 year, here is what your program might look like. In the summer, starting in early July, you would be taking 2 classes, and that's considered a full-time load when you're taking courses in the summer session like that. And so the 2 courses, an introduction to data science and a course on optimization and mathematical foundations for data science. In the fall, you would take a course in the algorithms and software foundations for data science, an introduction to statistical modeling, an ethics in data science class, and then 1 elective. The spring, you would also take 4 courses. Again, this is the 1 year plan. You would have a choice of either taking the data management for big data course or an accelerated computing for machine learning course. One of those 2, and then a statistical and machine learning class, and then 2 other electives. Now, those 2 electives might be, say, the alternate one. If you've taken the data management for big data as your required course, you could take the accelerated computing for machine learning as one of your 3 electives. But in fact, we have many electives. And I'll show you a long list of the already approved ones, and there will be more beyond that that can be considered as well. So this is the one-year plan. If you are not interested in pushing and taking 4 courses per semester, because that's a pretty strong requirement. A more typical for many of our programs is taking 3 courses per semester, and so that would result in being here 1 additional semester. The number of credits is still the same, but we would start with the 2 courses in the summer and then take 3 in the fall, 3 again in the spring. Then you wouldn't take courses that summer. In fact, you might want to take advantage of the opportunity to get an internship, which would be a nice way to be prepared to get a job afterwards. And then in the fall, you'd have two courses at minimum, typically being electives. So that outlines the 2 sort of typical full-time plans that we expect students to take. But we also, as I mentioned earlier, that the programs don't require that you be full-time. You could be doing this 1 course a semester or something else that fits your schedule a little bit better.
So Brian, maybe I could jump in. There's a relevant question to this, which is somebody had asked whether it's possible to start the program starting in the spring semester instead of the summer. Go ahead.
Great, that's a good question. So because we are starting a new program, the courses that are required in the program are scheduled in such a way that someone can start when we're beginning with the summer and finish in the spring. They also have some prerequisites among them. And so the courses that are offered in the spring typically have prerequisites of the courses that were offered in the fall or the summer before that. So in general, it would be a challenge to start in the spring. I would say unlikely, but if a student has a suitable background, we can examine that background and see whether there's whether that student would be prepared to be successful in the courses in any case. So I would say I would discourage it, but if it's important, we're happy to take a look and help you understand whether that's a possibility or not. But at the moment, our expectation is that students would start together in the summer, unless they already have background that covers the summer courses that we've listed here. And if you did have background, I should have mentioned that, if you did have, say, an optimization background, perhaps the optimization course in the summer is not something that would teach you something. And so we would be able to look at your background and then provide a waiver of that requirement and give you another opportunity to take a data science elective instead. And same thing, if you've got a computational background, maybe you don't need the algorithm software foundations course. Or if you've done data science as part of your undergraduate curriculum, maybe perhaps that would mean that you wouldn't need the intro to data science class. So we'll consider those on a case-by-case basis. It's not something that we have specific rules about, but something that we would look at your background and your transcripts and have a conversation with you about it.
So another question, Brian, that's relevant here is a question about, that the program is new, but the data science courses that have been, a lot of these have been taught, or similar courses have been taught at Lehigh for years. So the specific question is, are the course requirements, the GSCI courses, are these new courses with new instructors, or are they pre-existing courses that are just cross-listed for the new program?
Great question.
What I said.
The short answer is that these are all courses that have been designed to fit into the package that we needed so that we could offer the core of data science in 7 courses. That's a particular challenge, and for the most part, they are not identical to courses that are already offered at Lehigh in other forms. There is, of course, significant overlap with certain courses. And so if you've had certain machine learning course, as an example, the statistical machine learning course is going to cover much of the same ground. And so we would want to have a conversation with you about what you've had at Lehigh and how they would overlap and how we might want to give you some more flexibility if you've already seen some of these concepts before. Same thing, like I said, for some of the foundational courses. Maybe you've had them already in some undergraduate program. There are some courses here that are closer to being I won't call them an exact match, but a close match to other courses at Lehigh, and some that are further away, even though some of the concepts do overlap. So it's a great question. I can't give you a straightforward answer to it, but we're happy to discuss the situation with you. All right, Daniel doesn't seem to have any more questions for me right now, so we'll keep going. We're almost done. I just wanted to first show the set of elective courses that we've identified already as being relevant and pre-approved for data science electives. You can see that they span certainly the 3 departments that we represent, but also some from statistics. And there will be courses from other departments, and even courses that aren't from these departments that aren't listed yet, that maybe are new or weren't available when we first set up these pre-approved ones. Now, these are not all offered every semester. This is just sort of the combined set of courses that we know of that are on the books. All right, so I want to wrap up and give opportunities for other questions and have a more interactive time. I appreciated the questions that we've had as we went through. I know a few people joined late, and that's fine too. We'll be happy to answer your questions as well. And thank you.
Brian, there was Brian, there was another question, and now a couple coming in that I just delayed a little bit to the end. But the first one is a very specific question about are us three, or we the ones, you, me, and Parv, are we the ones that are going to be making the admission decisions?
This year, that is correct. We'll be the ones making admission decisions. The collection of faculty that will do that in future years will grow. And so at some point, we'll have a subcommittee, committee of the faculty that are involved with the data science program be responsible for that. But at the moment, it is all 3 of us. Yes. No, we don't take bribes, so that doesn't help. Yeah.
There's also another question about just, I guess really there are 2 questions here, although it's worded as one, which is if a student has already submitted an application to a different program like CSE or whatever, ECE, ISE, and I guess let me break it up into 2 questions. Suppose they have not been accepted, but they have applied. Can they somehow transfer their application to the program instead? And a related question is, suppose they have been accepted already to one of these other programs, can they transfer into the Master's in Data Science program?
All right. So one of those questions is easy to answer. And so let me start with that one. If you're already a student at Lehigh, there is a petition form. Lehigh loves petitions. There is a petition form that you can use to transfer from one program to the next. That doesn't mean you skip the application process. It just means that we're going to review your application materials that you submitted to your original program and consider them to make sure that they're valid before we approve the transfer petition process. Now, as far as applications, or if you've applied and been admitted, I actually don't know the answer to that. So I would suggest and request that you send us an email specifically about that. And let me, I'll just drop my email in the chat. That's not my email. That did not type correctly. Let me do that again. There's my email. And so if you can send me an email with that question or any question that we don't answer tonight, we'll be happy to talk to the right people to find out what the answers are. Next one, Daniel.
Yeah, these are, we're getting some tough ones coming. So how does employability at large compare between an MS in data science versus, I assume, an MS in computer science? And sort of a follow-up to that might be, what kind of person would benefit from one of them versus the other?
Great question. So I really think it depends on what you want to do. Data science is going to have some computational components, but it is not just computational courses. There's lots of things. There are lots of things in there that are from other disciplines, and certainly we know, because we know who's teaching these courses, and we prepared the program, that there are courses that come from all three of our programs, our departments, because that's where the expertise is, and that's why we've put them together in this way. If you want to mostly be a software developer, then a computer science master's is likely to be a better choice. If you want to be focusing more on the data rather than the software to build the data or to process the data, then data science is certainly the right choice. If you're somewhere in between, that is, you want to build software specifically to manage and process the data, then you probably want something in between. And it could be either degree, but you probably want to get, or maybe you have a bachelor's degree that gives you more of a, for example, gives you more of a software engineering background that you can then use to be more of a data engineer, or we typically might call them a data engineer. That would be a software engineer that's primarily building the infrastructure, the software to work with or manage or process the data. So I guess I'm going to be biased, but I'm going to suggest that if you're interested in either data science and working with data and getting the value out of the data as your primary goal, then clearly data science is the right place. If you're interested in building the tools for data science, then I would say data science is still probably the right place to help you understand how those tools will be used, to understand what's already, the technologies that are already in there. And then from that point, you can build on top. You can get some of that from a master's in computer science program, but you'd have to be intentionally looking for electives that would sort of fill in the gaps. I hope I answered that reasonably. Next one.
Can you speak to the reason for the 10% tuition reduction for the 2022-23 academic year?
It is not specific to this program. It is something that at least the College of Engineering, and I think most programs across Lehigh are doing right now. And so it's not something that's specific to us. Yeah, I mean, discounts, I'm sure you'll take it because it is expensive. Next question.
Yeah, there's a question here about, is there any financial aid? And Ishan put in a link that gives them some information from Lehigh, which is great. But is there anything else you want to add about that? Is there any financial aid for the program?
So there isn't financial aid specifically for the program. The link that Ishan has shared is good. If it's the one I'm thinking of, it's got a long list of programs that provide scholarships, partial scholarships, fellowships for people from a variety of backgrounds. And there really are opportunities out there, but Lehigh as a university and graduate programs like this typically don't have direct financial aid, at least not at the master's level. If you're admitted to a PhD program, that's a little bit different. In the engineering college, at least, it's common for PhD students to be fully supported, fully funded the entire time that they're here. But that's not typically the case for master's programs, in part because you're not here very long. And so we can't, even if we employed you, you wouldn't be here long to provide a lot of benefit for the employment. So that's unfortunately the situation as I understand it. I don't know if there are any other thoughts from Daniel or Parv about that. Okay.
Nope. Here's another one. Suppose you have a statistics major that's had a couple programming courses in R and SAS. Will this meet the programming requirements for admission?
Yes. The programming requirement is pretty basic. We want you to have had experience with arrays or vectors. We want you to know about loops and functions and variables, and that's enough. And so you should have had that from the kind of experience that you've described.
I think you've touched on answers to all these questions as far as I can tell. Let me just add one thing, just as a little bit of a follow-up of sorts to the question of, are the courses for the program just essentially cross-listed courses or not? And, Brian gave a good answer to that, but one thing I just wanted to stress a little bit is that for example, one of the courses over the summer is being taught completely new, and many of them are completely new courses. But as Brian said, it doesn't mean that there's no content from these courses that don't overlap with some other courses in some way or another. But the main thing I wanted to stress is that this program has been built in some sense from the bottom up in terms of the courses. We've had great support from the dean in terms of having this opportunity to design these classes exactly the way we want them for this program. So at the very least, courses are being modified, at the very least, designed, changed and modified specifically for this program, which is different than a lot of master's programs, not only in the US, but often in other just programs in general. When you tack on a master's, sometimes it's really just cross-listing courses. So I think that's a great question, but that's not at all what we've done with this program. All these courses are being designed specifically. They're the way the material is at least being modified, but everything is being done with the thought for this program for these courses.
Thank you. Exactly right.
So I think that's all that I see here, Brian.
All right. Thank you, Daniel. Like I said, I noticed a few people who came in as we were presenting materials. And so if you did not yet see the information that you were looking for, please feel free to unmute and ask questions. You can remember we have two Lehigh students here who can answer questions about Lehigh and their perspectives of Lehigh. But we're happy to chat. We're happy to answer questions by the chat mechanism or by voice. We'll hang around for a little bit in case you do have other questions. You don't need to stay if you're satisfied. Thank you.
Brian, do we have anything available for, if other than contacting you via email, which you've already written in the chat, if anybody wants to try to follow up with the PhD students, maybe an email or two to talk with them instead of here, just in case they feel more comfortable doing it that way. Is that an option that we can maybe set up?
We would be happy to connect people if that's what they would like to do. So I would say first reach out to me, and then we'll connect you with a graduate student. That'd be fine. We can do that with PhD students from any of the 3 programs, and we'll find someone who will be a good person for you to chat with. I do see that Grant asked a question about an undergraduate program, or undergraduate course. That's CSE 160, and the answer is at the moment yes. The undergraduate Intro to Data Science, it overlaps sufficiently that it would be counterproductive to require such students to take the Intro to Data Science at the graduate level. There are a few things, and we can tell you about those things that are a little bit different, but it's not worth taking the whole course again. So yes. Good question. I should stop sharing since we're not asking questions about those materials. I will say we are seeing applications already, and we thank you for joining us.
Okay. All right. Just see thank yous coming in and no other questions. So
thank you, everybody.
That's it. I'm going to personally log off and thank you, everybody, for coming. And everybody take care.